Okay, the second lesson in this periodic functions unit, we're going to look more specifically today at sinusoidal functions. Sinusoidal functions are sort of a special group of periodic ones. They're ones that in the equation themselves have the word sine or cos in them. And you should have seen these last year, but just in case you haven't, we're gonna look at them a little bit more in depth today. Okay. From dealing with rotational trigonometry, we know if we wanted to, we could find the sine of 30. We could draw that out. We could do a right triangle and say, okay, here's 30 and 60 and root 3 and 2 and 1, all those good things. And we can do that for any angle we want to. For our purposes, we're going to approximate these things. So using our calculators, we're just going to say, if I have y equals sine x, and x happens to be 0, sine of 0 is 0. And the sine of 30, that would be 0.5. The sine of 60 is 0.866. Call that 0.9. Sine of 90 is 1. And if we keep punching these in, we get 0.9 and 0.5 and 0. And then negative 0.5 and negative 0.9 and negative 1. And negative 0.9 and negative 0.5 and 0. And then we're back to 0.5 and 0.9 and 1, and so on and so on and so on. And if you happen to notice, we've started repeating ourselves. Specifically, when we got back to 0 or 360, we've completed a whole cycle. We could do the same thing with cos. The cos of 0, we could draw it out, do our special triangle, look over here and say, hey, cos is x over r, root 3 over 2, or make it easy, hey, cos of 0 is 1. And then 0.9 and 0.5 and 0 and negative 0.5 and negative 0.9, negative 1, negative 0.9, negative 0.5, 0, 0.5, 0.9, 1. Oh, start repeating ourselves again. Okay, back to 0.9, back to 0.5, back to 0, and so on and so on and so on. And you notice that sine and cos have almost the same values, and that should make sense because when you do a special triangles, 30 and 60 are just opposite angles in that triangle, right? So when we deal with sine and cos, we're dealing with things that are very close to each other. Okay? And we've made ourselves a table of sine function for all these nice numbers that we talked about when we did rotational trigonometry. Okay? If I wanted to graph those things, I could. The sine function, I started at 0 and 0, then 30, and about there was 0.5, and then 60 was 0.9, and 90 was 1. And then back down, and we got to 0, and then we start going to the negatives, and then we got to negative 1, and then back up again, and that was what a sine function looked like, which, if we kept going, would start repeating itself, right? We just talked about that. The cos function started at 1, and then it was at 0.9, and then it was at 0.5, and it was at 0, 0.5, and then 0.9, and then negative 1, 0.9, 0.5, back to 0, 0.5, 0.9, 1, and then it started repeating itself. So the cos function, I missed a dot there, it's okay, would look like that. And this would be cos, or y equals cos, and this would be sine. And these are both periodic functions. And we produce them by actually using our calculators on table of values. Okay. Now, it's great. We could make that table every single time if we wanted to. That wouldn't be hard to do. It'd be a little time consuming because there's a whole bunch of points in that table. But it's a little bit easier to work with what we call a 5-point table. Okay. The 5-point table is kind of the important ones, the ones where the graph changes direction. And I hope you noticed in the sine curve, 0, 90, 180, 270, and 360 were the ones that came out to nice whole numbers. The sine of 0 was 0. The sine of 90 was 1. 180 was 0. 270 was negative 1. And 360 was 0. And we call this a parent function, a starting point, if you will. From there, we could sort of make children and see what happens as we start changing things. The cos one is 0. Cos of 0 was 1. Cos of 90 was 0. Negative 1, 0, and 1. And these are things that should definitely be on your learning goal sheet because you can use these tables over and over and over and over again to the point you basically have them memorized. Okay. Based on yesterday's ideas, we can find our 4 important properties, if you will. Okay, the amplitude, if you look at your graphs, okay, the highest we ever reached, the max, was 1. The lowest we ever reached was negative 1. Okay, so max minus min divided by 2. Our amplitude would give us a total of 1 minus -1 divided by 2, 2 over 2, or 1. You have your amplitude for both curves. Our central axis for both curves, max plus min over 2, 1 plus -1 gives us 0. Okay. Both of these, when we got to 360, we started repeating ourselves. So our period was 360. And that sort of gives us our properties. And just a list of them right here. So amplitude, period, equation, and then range. Just to talk about range for a second, instead of writing the words out min and max all the time, sometimes we'll use this inequality notation. Okay, so by using this, we're saying that y is greater than -1. It never goes below -1. This is our minimum right here. Okay? But at the same time, it never goes above maximum of 1. Okay? So it's always less than 1. So when we start talking about range, we can use something called interval notation to say what values that our graph lies between -1 and +1. Okay. The nice thing about sinusoidal curves, the sine and cos, is we can start using our calculators and do some things with them, some kind of really neat things with them. Okay, so we're going to look at next is how we can start transforming these things, changing them. And again, this is something you did last year, but just to remind ourselves of what we did. Okay, A, K, and C, in these three spots, a value here, here, and here, can change my graph, change my my function, change the way it looks. Either make it bigger or smaller, or stretch it, or move it up or down, or things like that. And to do that, we're going to look at an online graphing calculator just for a second here. We call this Desmos, and later on this course, you'll be using Desmos to graph and solve some problems yourself. Okay. I'm hoping you would agree that this graph right here is a standard sine curve, goes up and down and up and down from 0 to 360. Okay, that's the black one right here. If you look on the left-hand side here, I've got different equations. I've got y equals a sine x. Okay? I put a number in front of a, it's going to do something. And if I grab the slider underneath it, and you can try this yourself if you want to go to the website. You can just type in the link there. Okay, as I move a, we notice that my graph starts getting bigger, starts vertically stretching it. The bigger a is, the bigger the graph is. If I make it 0, it's flat. But as I get bigger, and I go all the way up to 10, let's say, my graph changes. It gets vertically stretched. Okay? In fact, if you stop and think, the amplitude of this graph, well, my center line obviously is right here in the middle. That's 10. And this one down here is 10. So it sort of suggests to us that A is our amplitude. Okay, if I try the next one, look at y equals k sine x. That's the green one here. Okay. By putting a number inside the bracket, what does that do? Well, if I look at my graph, it seems that as it gets bigger and bigger and bigger, I get more and more and more graphs in the same point. I'll keep it a little small just right now to see. Okay, but by the time I get to 360, and 360 is over here, I don't have one cycle, I have 1, 2, 3, more than 3, right? The bigger k got, the more cycles I had. In other words, my graph is getting horizontally compressed. I can fit more cycles into a smaller area. Okay. If I look at the last one, okay, y equals sine x plus c, and I start moving that slide around, my graph starts moving. Okay. It's still the old sine curve, but it's moving up and down. Up and down. The higher it gets, okay, it's a positive. Look at positive 6.7, it went up. And if I go over here, it's going down. Okay, so my C moves my graph around. So in case you missed some of those things, okay, here's a little list for you guys. Things you should notice. Okay, read it over, see if it makes sense, and then we'll try some examples. The only one thing I want to point out is number 4 down here, okay, the idea of range. To find out a max value, okay, we have a little formula. C plus A will give us our maximum, our amplitude and our center axis put together. So start at average and add your amplitude, you'll get your max. Or to get the min, you start at average, the central axis, and you subtract your amplitude and you get your min. And we'll look at some examples of this in a second, but this is sort of the key to the lesson today. So make sure you read those over and process that a little bit.